Hello and welcome to another simple science video where we aim to explain simple scientific concepts. And on this series of kinematics, we are going to be concerned with acceleration. So what is acceleration? Of course, you hear it all the time. Race cars accelerate when they turn around the bend or they just speed up. Now, it is related to how things change velocity. But the formal definition of acceleration is different. It is the rate of change of velocity with respect to time, where velocity is the rate of change of displacement. Now, as you can deduce, acceleration is therefore a vector quantity. Moving on, a body can accelerate because acceleration is a vector quantity when it changes speed. For example, this velocity vector has a speed of 2 meters per second, and if the speed increases to 4 meters per second, then we can say that it accelerates. Why? Because the speed changes. And it can also change direction to accelerate. For example, this 2 meters per second vector, again, can change direction at a small angle to reach 2 meters per second at a different angle. Therefore, it changes direction. Therefore, this accelerates. And here are two diagrams to show this. Acceleration can occur when you increase speed from 10 meters per second to 30 meters per second. And you can also decelerate when your speed goes from a higher speed to a lower speed. Now that is completely common sense. Also, this can be taken into consideration in circular motion. For example, this car is moving around a perfect circle at a constant speed of 10 meters per second. It is accelerating, although its speed is staying the same because its direction is changing. Okay? Now, let's get to some maths. We can define acceleration as the rate of change of velocity, and therefore it is numerically equal to the change of velocity over the time taken during this change of velocity. We can give Greek symbols to that as A equals delta V over T, right? And delta V is simply the velocity, the final velocity minus the initial velocity, and therefore we come up with the abbreviated symbol formula of A equals V minus U over T, where V is the final velocity and U is the initial velocity and T is time. And let's put these ideas into work. First, a car accelerates from 10 meters per second to 40 meters per second in 10 seconds. Now calculate its acceleration. So the first thing you do is you're going to substitute values in. What is the final speed? It's 40 meters per second. What's the initial speed? It's 10 meters per second. And time is 10 seconds. And there we go. And if you calculate this quickly, you will get 4 meters per second squared. Very straightforward. Plug it into the formula. Simple IGCSE stuff. Moving on. When an object is dropped and it undergoes free fall, calculate its final velocity after 10 seconds. Now we put in the formula. Now, in this situation, we are not calculating the acceleration, rather we are calculating the final velocity. So we're calculating V, essentially. We know U is 0 because we're dropping it. The initial speed is 0. And the time taken for this entire acceleration is 10 seconds. And there we go. 10 meters per second squared is the acceleration of free fall. It's acceleration when something is dropped in a vacuum, which is what we're assuming here. So we're going to rearrange our calculation to give that, and that should give a V of 100 meters per second. So that is our two examples of how you can use the very essential formula V minus U over T and rearrange it to get the value of V. Awesome. If you like this video, please like, comment, and subscribe, and wait for more. The next video is going to be based on kinematic graphs. Okay? Perfect. Goodbye. Have a good day.